So howdy everybody, welcome back. Some more root beer action coming at you as we continue a series of contest videos. We're going to be continuing on with the 2014 Cimc. So in this particular video, we're going to be looking at question number 4. Let's take a look at it. I think it's a uniquely Canadian question. It's talking about places in Ontario, and it's a question about depth of snow, as we can see just from glancing at the first line. So at a given time, the depth of snow in Kingston is 12.1 centimeters, and the depth of snow in Hamilton is 18.6 centimeters. Over the next 13 hours, it snows at a constant rate of 2.6 centimeters per hour in Kingston, and a constant rate of X centimeters per hour in Hamilton. At the end of these 13 hours, the depth of snow in Kingston is the same as the depth of snow in Hamilton. What is the value of X? So this seems like sort of a word problem you might get in a textbook, actually. It sounds like there's a lot going on, but really what it's going to boil down to is just a simple equation in X. Just solve for X. It'll be a linear equation. But let's draw ourselves a little bit of a picture of what's going on. First, we need a brand new piece of paper. Which I thought I just clicked on. There it is. Alright. Oh, we've gone too far. Program's running a little slow, I guess. Okay, well, we'll use those pages eventually. So what have we got here? So at the start of the 13 hours, we have let's just draw a little bit of buildings for Kingston. Not Kingston, Kingston, Kingston. And so their snowfall has reached a starting height of something. I'll go back and check it again in a moment. And we'll draw a little picture of Hamilton. Maybe Hamilton has more of a skyline, but it's still got some houses. And maybe it's got a nice fluffy tree. I don't know. So I'm aware that centimeters do not make things taller than buildings, but we just have a nice little picture. Have fun with the question. So Kingston starts at 12.1 centimeters. Hamilton starts at 18.6. And 18.6 centimeters of snow. So after 13 hours, what's our snowfall going to look like? Well, here's Kingston again. And here's Hamilton. Draw that tree a little better this time. So they already, so Kingston already had 12.1, but then we added to it 13 hours of, what was the snowfall? 2.6, and in Hamilton it'll be 8. So 13 hours. At 2.6 centimeters per hour. That's our new snowfall. So he was at 18.6, and now we have 13 hours of a rate of X centimeters per hour. And what do we know? We know we have the same height of snow after those 13 hours. We didn't start off the same. Hamilton had more snowfall, but we definitely have added more. So what do we know? Well, we can equate these two. We can say 12.1 centimeters starting for Kingston plus 13 times 2.6 is going to be equal to the same amount of snowfall as starting with 18.6 centimeters and adding on 13x. Let's get rid of the x for times, just so that we're not confusing ourselves. Put a little dot in there, the dot for multiplication. Whoa. .6. Okay. So 12.1 plus 13 times 2.6 is the same as 18.6 plus 13x. So what do we need to do? Well, we need to start simplifying and bringing everything over to one side and just solving for the x value. So 12.1, not very interesting. How about 13 times 2.6? Well, we can get that out with a calculator, or if you're good with decimals, you could probably work that out as well by hand or in your head. 33.8. Let's just check, does that make sense? Well, 13 times 2, that'd be 26. So 33, it's in the neighborhood of 26. So that's probably right. This 18.6, we can bring it over to the other side by subtracting. And we know all that's going to be equal to 13x. X centimeters per hour is what we're looking for. So we just have a whole bunch of numbers over here. We can simplify it. So 33.8 plus 12.1, that's 45.9. And then if we subtract off 18.6, we get 27.3 centimeters of snow. It's 13 hours times x centimeters per hour. So we want x. We just divide through by 13 on both sides. So 27.3 centimeters over 13 hours equals 2.1 centimeters per hour, which equals x centimeters per hour. So x is equal to 2.1. And as that is all we are asked for in the question, let's just make sure, what is the value of x? Bam. We read through the question right. We have all our numbers right. 12.1, 18.6, 2.6. Okay, all the numbers were correct. And we did get a nice final answer. We got 2.1. We didn't get some weird lengthy decimal expression. So we can be reasonably confident that 2.1 is the answer we want. If we wanted to, we could sub it back into this equation and show that 12.1 plus 33.8 is in fact 18.6 plus 13 times 2.1. That's something we could do to double check, but we want to leave enough time for those Part B questions, so 2.1 will have to do, and we can move on to the next question, which we'll see in the next video. So thank you so much for joining me, and I'll see you for question 5 next time.